This class will learn about circles. What is a circle? Okay, you see everywhere circle. Your cycle wheel is a circle, your bus wheel is a circle, and your rupee coin is a circle. You see everywhere circles right around you. Finally, your marks also circle, right? That's a zero also circle. Isn't it? Okay. So you see circles everywhere in the real applications, okay? So we need to know a lot about the circles in the higher classes. Now we see some basic concepts in the circles, okay? First we'll see what is a circle, okay? Can you plot a point just 3 centimeters from this point, okay? I'm just giving an example. Okay? Can you mark the points 3 centimeters from this point? Yes, you can mark, right? You can use the ruler and you can mark, right? For example, you use the ruler and just put the ruler here, right? How many centimeters I said? 3 centimeters, right? This is 1 centimeter, 2 centimeters and 3 centimeters, okay? So this is the 1 point, okay? So how many points you can have the same distance from this point? How many points it has? It has so many points, right? If you rotate this scale and make another point actually from 3 point, you'll get another point here, right? Okay. So this is also having from here to here, right? It is also 3 centimeters, right? Okay. So if you rotate it further, you can also mark another point as 3 centimeters, right? So this distance also 3 centimeters, right? The closed scale. Okay, so this centimeters also 3 centimeters. So if you start joining all the points, okay, all the points having the 3 centimeters from the fixed point, okay, so you get the point here and here, like that, right? So if you keep joining all the points which has the 3 centimeter from this point, right, it will form a circle, okay? So you can check it. This is the 3 centimeters and this is the 3 centimeters, okay? So you get so many points having the fixed distance from the fixed point, okay? That we are calling as a circle, okay? This is calling a circle. Circle definition is right. So connecting all the points having the fixed distance from a fixed point. This is a fixed point as a center and it has the fixed distance, and all the points we are connecting, it's having the fixed distance from the fixed point, right? So then that is called a circle, okay? So this may be 3 centimeters, 4 centimeters, 5 centimeters or 1 meter and anything, okay? It has the fixed distance from the point, right? See, now I'm drawing a circle, you see. This is, when I touch it, right, this is a fixed point. I'm just drawing all the points I'm connecting. Okay, these are circles. So this circle has the 5 centimeters and this circle has 3.6 centimeters and this circle has this circle has 1.8 centimeters. Okay, so that fixed distance I'm talking right from the fixed point. So that distance we are calling as a radius. Okay, radius of the circle. In this circle, this 3 centimeter we are calling as a radius of the circle. Okay. So it's clear, right? So you know what is circle, okay? This is the line, okay? It won't change the direction, okay? You just need the 2 points to draw a line, okay? If you know the 2 points, you just join them, it will form a line, okay? So these are the lines, right? Okay? So these are the lines, okay? So I drawn so many lines, okay? Now we will see between the line and the circle some kind of a relation. Here I have drawn the one circle and few lines, okay? So this is the circle. Let's name the circle as C1, circle C1, okay? So as a fixed distance from the center, let's mark the fixed distance, okay? This is the center, okay? Center of the circle, okay? So it has some radius. So I said, what is radius? Or that is fixed distance we are calling as a radius. So we are calling radius R, okay? So the circle name is C1 we defined, and the fixed distance from the fixed point, right, that we are calling radius, right? So here I have drawn the few lines, okay? So line means, right, it is not ending these 2 points. You can have the extension of the lines, right? So I just drawn a few segment of the line, okay? not the full length. So you can draw length, okay. So what are the options we have between this line and this circle, we will see. For example, I pick one line, okay. So this line is approaching towards circle, okay. So this line may not touch the entire circle, that is having one option, right. So this line is not at all touching to the circle, okay. That one option have. Suppose if I am moving this line, okay, this another line, not this line, another line having here like this, okay. So it can touch at 2 points at the circle. So that is 1 point here and 1 point here. 2 points, it is touching the circle right here. Similarly, if I keep moving this line, okay, so it is and all touching at the 2 points. This is another scenario, okay. So that line can touch at 2 points to the circle. So all the 2 points. There is a third scenario we can see actually. It can touch at only 1 point to the circle. So if you just starting touching to, right, it can touch only 1 point to the circle, okay. This is the third scenario. So totally we have seen 3 scenarios here. One is that line is nowhere is touching to the circle. Another scenario, it can touch at 2 points to the circle. And the third scenario, it can touch at 1 point to the circle, okay. So here I have drawn the 3 scenarios. Okay, this is the line actually. Let's take this line as some AB line, okay. So this AB is the line, okay. So this line is not at all touching to the circle, okay. Then the relation between the circle and this line, right, it is not intersecting at all, okay. Those are separate. Those are not touching to the each other, okay. So that's called a not intersecting, okay. The another scenario which I was explaining, it can touch to the 2 points. The same line can touch to the 2 points, okay. So if you move right, any instant, right, it can touch the 2 points. So it touched to 1 point here and 1 point here. Let's take these points, some PQ points, okay. So it can touch to the 2 points. These kind of scenario we are calling the secant line, okay. When it is touching to the circle at 2 points, that's called the secant, okay. Then the third scenario is that, right, it can touch to the only 1 point, okay. Then it touched to only 1 point here on the circle. That scenario we are calling the tangent, okay. Then this line is tangent to the circle we are calling, okay. Then this line is secant to the circle, okay. That means it can touch to the 2 points. Then this line is not at all intersecting to the circle, okay. So this line F, okay, is not at all touching to the circle C, right. This line we are calling the non-intersecting line, okay. Suppose this line having here, okay, this line is called the secant line, okay, having the 2 points touch points here and here, okay. The 2 touch points. So these 2 are the touch points, right. So I just mark the 2 touch points here. Okay. Now I am moving the line. You see the touch points are become the 2, right. So how it's moving, you can see, right. These touch points are the 2. D and E is the touch points for say. This line is called the secant line, okay. When it move away, there is no touch point. It's called the non-intersecting, okay. So when it's trying to touch the circle, right. So at the 1 point, if it touch it at, okay, that point we are calling this line is called the tangent to the circle, okay. This line we are calling the tangent to circle. And what we can observe here, right, when it has the secant line, it's just moving and approaching the 2 points will become the single point. That point we are calling as a tangent to the circle. Now I am drawing a tangent to the circle. Let's see, I am drawing a tangent to the circle. Let's take this as a tangent to the circle, okay. Let's take this as a tangent to the circle, okay. So now, if this is a tangent, right, so how many tangents can draw at a one given point, okay. Only you can draw one tangent. Why? Because, right, so tangents, so this is a tangent at the given point. If you are taking another line having slightly inclined, right, so if you make it inclined and change the angle, and if you try to intersect at the same point, it will touch the 2 points, okay. You cannot touch at the single point. At the single point, if you are changing the angle, right, it is at a single point, okay, it can have only one tangent, okay. It cannot have the many tangents at this given point, okay, because it has many lines. You can draw. So you can see here, right, I will draw a few lines here, see. So like this many lines I can draw. If you, this point, if you are taking, right, for example, For example, I'm moving this line. Okay, this point, if touching to the F point, right? It is having the 2 points touching to the circles. You can see here. This is 1 point touching and this is 1 point touching, right? So it is touching 2 points to the circle. So this is not the tangent. If you take this line, okay, if you take this line and moving, and if you come to closure, right, closure and zoom, right, it does also touch to the 2 points. It cannot touch 1 points. Only one line can have the 1 point touch, and one tangent it has at a single point. Okay, tangent line to the circle is it touches only 1 point to the circle. Okay, and another point you studied is there is only one tangent at a point of the circle. Okay, to each point it has the only one tangent. Okay, it cannot have the more number of tangents. Okay, so another point is, see, the tangent to a circle is a special case of the secant. Okay, if this line is a secant line, right, so it is touching to the 2 points here. When you are moving the secant line closer to the edge of the circle, right, it can touch to the only 1 point. Okay, that means it's a special case of the secant line is a tangent. Okay, that means when it's touching the 2 points, it's called the secant, and it's keep moving that secant, that line, and touching to the only 1 point at the circle is called the tangent, right? That means is a special case of the secant. Okay, now we will see how many tangents can be drawn from a point. Okay, so now what are the options we have to have the point from the circle? We have the 3 options. Okay, so the first option is the point can have the outside the circle, right? So for example, it can have the point here, like that outside the circle. That is one scenario. Another scenario, the point can have on the circle like that. So it can have here, it can have here, like that. On the circle, it can have the another scenario. Another scenario is that point can have inside the circle. Okay. So do you see any other than these 3 options? The point can lie down. Okay. So as per this in a planar, in coplanar, so these are the options. Okay, we have. Now we'll see how many tangents can be drawn from the each scenario. Okay, so if point is there inside the circle, okay, so it cannot form any tangent because the line is passing through this point, right? Okay, so the line is passing. This is the point, right? Inside circle. So it touches at the 2 points in the circle, right? So if it's touching 2 points, it becomes secant line, not the tangent, right? So if you draw any line, okay, any direction like this, okay, going to that point, okay, it is touching at 2 points to the circle, here and here. If take here like this, right? So it is touching here and here like this. It's touching at 2 different places to the circle. That means it's forming a secant line, not a tangent, right? Okay. So that's okay. So now we see another scenario. Okay. Let's take a circle. Okay. Now, if the point is there on the circle, okay, for example, it is there, okay, on the circle. We can draw one tangent, we can draw. That we know, right? We have seen, right? So we can draw a tangent. On one tangent, we can write. Okay. So whatever the point is there on the circle, you can draw one tangent. Okay. So, okay. Now we'll see third scenario. The point is there, the line outside the circle, right? So outside the circle, it is there, the point is here. Okay. For your convenience, I have put it the somewhat distance away. Okay. From here, how many tangents can be drawn? You can check it here. Okay, from here, one tangent can be drawn like this. Tangent can be drawn like this. Okay. So from the external point, okay, that's what I'm saying. So from the external point here, let's take the point P. Okay, you can draw the PQ, PR. Okay, you can draw the 2 tangents. Okay, so it's touching to the circle at this point and at this point. Okay. So we have seen 3 scenarios. One is the inside the circle, it forms the secant line. So there is no tangents. It is the point is lying on the circle. Then we can draw one tangent. And if the point is there outside the circle, we can draw the 2 tangents. Okay. Clear, right? Let us draw a circle. Okay. So this is the center of the circle, and this circle name is C1. Okay. Let's take C1. Okay. So I have drawn a circle here, and this is the line. Okay. It's the line L1. Okay. So this line is tangent to the circle. Okay. So tangent means it touching to the point to the circle is, let's take this is the point P it is touching, and center of the circle is O. Okay. So this theorem says that, right, at any given point on the circle, okay, if you draw a tangent to the circle, how many tangents can be drawn onto the one point? We can draw only one tangent, right? So this is the tangent we have drawn to the at the point P. Okay. Then what it says, right? The line. Okay. Let's take this line is AB line. Okay. So this OP is the joining between the center and the tangent point, right? So this theorem says the OP is perpendicular to the AB. Okay. We need to prove this theorem. Okay. We need to prove that this OP line is perpendicular to the AB. Okay. So AB is the tangent to the point P on the circle, right? So we need to prove that this has 90 degrees angle. Okay. So let's take any point on this line. Okay. Let's take this point. Okay. So what is let's take this point as arbitrarily some Q. Okay. So this point Q. Okay. If we draw these 2 points. Okay. So you can observe here, right? This is not so. You can observe one thing here. Okay. This OP is the radius of the circle, right? This is the radius of the circle. So if you observe this, this is OQ, right? This is the O point and Q. Okay. If you observe the OQ, it must be greater than the OP. Okay. So whatever the point you have taken on this tangent line. Okay. If you take point here, next to here also, you can clearly observe what we can observe, right? It is just crossing the circle. You can see it is only this point, right? It has it is there. R is the radius of the circle, right? From this point is the radius of the circle. All other points you can see, it just move away point also, it is just crossing the circle. Crossing the circle means all the points other than the P, okay? Other than the P. P is the tangent point, right? Other than the P, it is just crossing the circle, right? So definitely this is the point O, I said, right? This is the OQ. Definitely all the points other than the P, the distance is greater than the OP. Okay. Clearly stated that OQ is greater than the OP. Okay. So what does it mean? Okay. If you take one point, if you take any line, okay, randomly you draw just one line. Okay. Okay. How do you find the distance between this point and this line? Okay. So how do you find the distance between this point and line? Okay. So how we will find the perpendicular distance is called the minimum distance. Okay. So this is the all longest distance to the line. Okay. All the points having longest distance. Whichever is the perpendicular to that line edge, that is the shortest distance between the point and the line. Okay. So you can see here. Okay. This has some angle. This angle keep coming and closure. When it becomes the shortest distance, it becomes 90 degrees. After that, again, it keep going to reduce the angle. Okay. So hence it's a proved. Okay, it is only 2 points to highlight when you are proving the circle. What you need to write? The shortest of all distance of the point O to the point XY. So OP is perpendicular to the XY. Okay, is that right? Whenever the shortest distance between that point and that line, right, that is always having the 90 degrees. With that we will prove this. Okay, so we prove that here the OP is the shortest distance among all the points. That's the reason this OP is perpendicular to the AB. Okay. Only you need to highlight one point. Okay, while proving this theorem. Okay, you need to prove that OP is the shortest distance among all the points along the line. Okay. If you prove that, then this theorem is proved. Okay, because the shortest distance from a point to a line. Okay, that having the 90 degrees angle. Okay. So angle OPQ is equal to 90 degrees, right? This is proved.